Dear students, this lecture is completely for solving numericals on dielectrics and elasticity. Look at the first problem. If an electric field 100 volt per meter produces polarization of 0.1 into 10 power minus 11 coulomb per meter square, find dielectric constant and susceptibility. Dielectric constant is epsilon r. What is epsilon naught? This is for free space. Dielectric constant for free space. Epsilon r for a given medium we have to calculate. For air it is 1. Now it is for some material dielectric. Calculate susceptibility. What is susceptibility? It is represented by the letter chi. Now we know polarization P is equal to epsilon naught into epsilon r minus 1 into E. Okay? So now rearrange this expression. Epsilon r minus 1 is equal to P by epsilon naught E. P is given. This is P. This is electric field. Substitute here. P is 0.1 10 power minus 11. Epsilon naught 8.85 10 power minus 12 electric field. So polarization we get it. Epsilon r we get it. Now what is susceptibility? Susceptibility means ability of a material to get polarized. Permeability means ability of a material to get magnetized. So this is dielectric, electric field, ability of this material to undergo polarization. So its susceptibility is given by epsilon r minus 1. This term is called as susceptibility. Okay. So susceptibility is equal to chi is equal to epsilon r minus 1. You get epsilon r from this minus 1. Do that. This is very easy question. Okay. Now look at the second question. An atom of a dielectric kept in electric field of 10 power minus 2 volt per meter produces a dipole moment. Dipole moment means mu. Okay. 10 power minus 12 coulomb meter. Find polarizability. See here it is polarization that is given. What is polarizability? What is the difference between polarization and polarizability? Polarizability is obtained from this expression. Look at this. Dipole moment is proportional to applied electric field. An atom when kept in electric field, effective center of positive and negative charges get separated. So that produces a dipole. That creates dipole moment. Dipole moment is also equal to charge into separation between the two charges. What is a dipole? Two equal and opposite charges separated by a small distance. What is a dipole moment? It is equal to alpha into E or charge into separation distance. Now mu is given in this expression problem. This is mu 10 power minus 2 coulomb meter. Electric field is given. So alpha is equal to mu by E. We get around 10 power minus 10 farad per meter square. See, unit of polarizability is farad per meter square. Unit of polarization is coulomb per meter square. Is it clear to you? We'll go to the next numerical. See, on polarization, the numericals are easier. You can easily score marks. Find the polarization if the dipole moment is 10 power minus 12 coulomb meter and 10 power 16 atoms per meter cube are present. Correct? Now you know polarization is equal to dipole moment mu by per unit volume. It is also equal to epsilon naught epsilon r minus 1 into E applied electric field. So now mu is given. What is volume? Per unit volume 10 power 6 atoms are there. So this can be written as, if there are n atoms per unit volume, then it is equal to 1 by V. Correct? Therefore, P is equal to n mu. So 10 power 16 into mu is 10 power minus 12. This is the unit of this is the polarization. How do you get the unit? P mu is coulomb meter. This is meter cube. So meter square. Coulomb per meter square. Okay. Now we'll go to the next numerical. Find the extension produced in a wire of length 2 meter, radius 0.013 into 10 power minus 2 meter, due to a force of 14.7 Newton. Find the extension produced, means this is related to Young's modulus, change in length. Therefore, given y is equal to 2.1 into 10 power 11 Newton per meter square. Now, we know Young's modulus is equal to longitudinal stress by longitudinal strain. So, force per unit area is stress, change in length by original length. What is asked is extension. What is the change? This is asked. Correct? Original length is given area pi r square, wire, circular wire. So it is pi r square. So now I will take expression for delta x. Delta x will be f by pi r square into x by y. Correct? So f is given 14.7 Newton. Then x is length 2 meter, pi 3.14, radius 0.013 into 10 power minus 2 square into Young's modulus 2.1 into 10 power 11. Is it clear? So to find extension, the elongation, you have to use this form. So many Newton per meter square. We'll go to the next numerical. This is on torsional pendulum. Couple per unit twist. Calculate the angular twist. Okay, of a wire of length 0.3 meter and radius 0.2 into 10 power minus 3 meter when a torque of 5 into 10 power minus 4 Newton meter is applied. Given eta is equal to resistive modulus is given. Okay. Find the angular twist. Couple per unit twist we have derived in the previous lecture. What is the formula? Torque. See, this is for this. You have a cylinder. This is fixed. Okay. Now this upper end is fixed. This is twisted. This plane will come here. We have derived torque will be equal to pi into resistive modulus r4 theta by 2L. Now theta is twist, angular twist. Angular twist, theta is equal to torque into 2L into pi eta r4. Correct? So we have eta given, radius, r is radius given, L is, so torque 5 into 10 power minus 4 to L is 0.3, pi 3.14, eta 8 into 10 power 10, radius 0.2 into 10 power minus 3 to the power of 4. See, you will get the answer in radians. So many radians. So next numerical, it is on dielectric. If, okay, if polarizability is if polarizability is 7 into 10 power minus 4 farad meter square. So it is farad per meter square, farad meter square, this is alpha. Okay. Find dielectric constant if material has 3 into 10 power 28 atoms per meter cube. Now, can you find out what formula to be used here? Should we use mu dipole moment is equal to alpha into E, electric field not given, correct? Then which formula? See, they have not mentioned that you should use Clausius-Massotti equation. See here, from Clausius-Massotti equation, what do you have? Epsilon r minus 1 by epsilon r plus 2 is equal to n alpha by 3 epsilon. Epsilon r, find dielectric constant, we have to find epsilon r. Polarizability alpha is given, n is given here, correct? So sometimes please read the problem 2-3 times and try to identify the expression. Let us say in the exam, after reading the question, you don't come across any formula, you don't understand the problem itself. Don't leave the problem like that. You know this problem is on polarization. Please write the formula whatever you remember. For formula at least you will get 1 marks. This is a very useful strategy. In video exam, suppose you get a numerical on de Broglie theory. Write the formula, lambda is equal to h by mv. Lambda is equal to h by root of 2me. Suppose you get a problem on uncertainty principle. Delta x into delta p is equal to h by 4 pi. Delta E into delta T is equal to h by 4 pi. Suppose you get a problem on conductivity. Sigma is equal to Ne mu. Correct? You get a problem on probability of occupation. F of E is equal to 1 by E power E minus Ef by Kt plus 1. So plus read the problem. If you are able to understand what is it about, write the new formula you remember about those parameters. You get 1 mark for the formula. Correct? And if there are if you find any discrepancy, if you feel there is question itself is wrong, in the problem necessary data is not given, don't leave the problem like that. Just write the question number and write the formula you remember, show the parameters you remember. Don't solve it, but at least write question number and write some formula whatever you remember. For that you get full marks. Last question paper in January there were some mistakes. People did not attempt it and lost marks. Those who just wrote the question number and wrote the parameters, wrote the formula they knew, and they stopped in the middle. So they got full marks. So please use all these techniques. Okay, we'll go to the next numerical. It is on torque. Calculate the torque required to calculate the torque required to twist a 1.5 meter long wire of radius 0.04 into 10 power minus 2 meter through an angle of pi by 45 radian. So what is that? This is theta. Theta value you must substitute in radians. Correct? So this is again torque tau is equal to pi eta r4 theta by 2L. Correct? Torque is asked. So pi 3.14. Rigidity modulus is given 8 into 10 power 10 Newton per meter square. So 8 into 10 power 10. Radius 0.04 10 power minus 2. Theta is pi by 45 radians. Right as it is. Okay. 2 into length 1.5. So solve this. Unit of torque is Newton meter. Torque is nothing but force into distance. It is also called as moment of force. Correct? Couple. Couple is also force into distance. So solve this. Now the next numerical. It is on elasticity. Find the force required. Find the force required to produce an extension of 1 millimeter. To produce an extension of 1 millimeter in a 2 meter steel wire if diameter is equal to 1 millimeter, y is equal to 2 into 10 power 11 Newton per meter square. Young's modulus is given. So you all know Young's modulus is equal to stress by strain, longitudinal stress by longitudinal strain. Stress is force by area, strain is change in length by original length. Now force is asked, this is asked. Extension x is, this is delta x. Extension of 1 meter. 2 meter long wire, this is x, original length. Okay. Now diameter is 1 millimeter. What is radius? D. Circular wire. So you have to take area as pi r square. F by pi r square delta x by x. So force is asked. F is equal to y into delta x by r square. Cross multiplication, realign. Y is given, delta x is given, x is given, pi, you know, r radius. So many newtons you have to substitute. Okay. So now we'll take another problem. This is on single cantilever. Is this clear? Now a problem on single cantilever. A bar of length, a brass bar of length (1 meter), area of cross section 0.01 millimeter square, is clamped horizontally at one end. A weight 1 kg is applied at the other end. Okay. What is the depression produced? What is the depression? Given Young's modulus is equal to 9.7 into 10 power 10 Newton per meter square. So what is the problem? So here is a bar. Yesterday in the previous lecture I showed you it is a beam. This is single cantilever. This is fixed horizontally to the rigid support. Okay. Now it is loaded here. Is equal to weight is mg 1 kg. See, this is not actually weight. In the question paper they are mentioning weight, but it is mass. 1 into acceleration due to gravity 9.8. Length is 1 meter L. Correct? Young's modulus is given. Now it bends, so there will be bending moment. By using the concept of bending moment, we have to calculate depression y. We know depression y is equal to, we have the formula, weight length by 3 Young's modulus into geometrical moment of inertia. Correct? So now, geometrical moment of inertia, what is the formula? Area into z square or k square. This is radius of gyration. Area, so you can use the letter A, K or Z. Area is length into breadth. Cross sectional area is given in the problem. 0.01 millimeter square. See here, minus 3 square means 10 power minus 6, correct? Meter square. Area is given. Now you need K. Assume this to be a rectangle. For rectangle, we know area is B into D. So into 10 power minus 6. Assume B is equal to D. So D square is equal to 0.01 into 10 power minus 6. Correct? Assume length and breadth and thickness of this beam are equal. So you got D square. Now, see here, K square, radius of gyration for a rectangular cross section. While discussing bending moment, we have done two cases, rectangular cross section and also circular cross section. For rectangular cross section, by definition, we can prove that radius of gyration K square or Z square is D square by 12. D square, you know, substitute here, calculate K square and substitute here Ig. Correct? See, this problem is not a direct problem. They have not given you thickness, they have not given you breadth, they just have mentioned area of cross section. So assume the area of cross section is B into D, and I have assumed B is equal to D. Correct? So D square, you get this. By doing that, you get depression small y. See, this is small y, this is Young's modulus, capital Y. So please follow these things. These numericals are very, very important. Please practice it. And if you have doubts, please contact us. See, I have not discussed very simple problems on dipole moment. For example, I'll give you a simple problem. See here, find dipole moment mu if a dipole has Q is equal to 0.1 into 10 power 0.1 into 10 power minus 19 coulomb and separated by 0.1 nanometer. Correct? Dipole moment mu is equal to charge into separation distance. 0.1 into 10 power minus 19 into x is 0.1 nanometer minus 9. So many coulomb meter. Is it clear to you? So this is a very simple problem on dipole moment. You may get a problem on Poisson ratio. See here, find the Poisson ratio if elongation strain is 1 millimeter and lateral contraction is 0.1 millimeter. So you all know Poisson ratio is lateral contraction by longitudinal expansion, 0.1 millimeter by 1 millimeter. So sigma is 0.1. Is this clear? It's a very simple numerical. Now we'll see the last problem. See here, find internal electric